Hi! In this video we're going to learn how to separate stains. So I will be following the tutorial that is already part of the QuPath docs. We've got a very nice written down tutorial, a video as well. It starts with fluorescent images. I'm not going to do that because I like bright field images more. So I'm just going to pop this page to my other monitor and you'll see what I do on QuPath here, and then you can follow along. So let's start with bright field images. The first thing I'm going to do is create a project, and then I'm going to drag and drop some of the images that I'm interested in, and then we have to select the type for all of them. So this is H&E, this one is that, this one is, and again this one is H&E. I wanted to start with bright field because what we have here is color information. So the channels we have here are RGB, and you can see the values here of the red, green and blue values for each pixel. So in this case, in H&E, you can see that you've got pinks and purples, and then some other tones that shouldn't be there. That can happen with stain artifacts, mistakes. You've got a bit of brown here, I saw previously, a bit of green here. So that can happen, but that is not actually part of the information you want. So let's try to avoid those areas. Okay, the first thing we need to do, apparently, is to check in the brightness and contrast pattern here, which you can also do with Shift and C in Windows at least. Okay, this is the histogram with the values of the red, green and blue channel, and if you check just hematoxylin, okay, it's been automatically deconvoluted. So you've got the hematoxylin there, sorry, the darker, more purple areas, and then the eosine, which are the pinks. And you can see this is not like an actual mask, so you don't get very rigid regions of here is the eosine, here is the hematoxylin. You just get more or less intensity of each of these channels, and then the residual as well. Yeah, so this is the original. This is when you try to extract hematoxylin, and this is when you try to extract eosine. Let's see what the tutorial says. Right, so we can see this from the very beginning, because when we said that this image was an H&E image, it automatically loaded the stain values that are normal for H&E images, and it's using that for the stain separation. But the reason why I wanted to open this image as well as this other one is because they have very, very different color appearance. You can see that this is very, very white and bright, and this other one is much more subdued, it's more creamy. That's because they have different ICC profiles, and I wanted to see if they have the same stain separation vectors, even though they're not the same and their color information is probably not the same. What happens if you just apply the same vectors? So here I'm going to open up this one. Okay, and let's synchronize viewers, because I want to, they're not synchronized but in the wrong place. Okay, can you see the difference in color? Because I want to see if the pixel values are different as well. So let's go to a very specific spot. Oh, and you can see it as well. You've got some very bright blues here. This pixel is really not the same as this one. This is a 35, 27, 78, and this one is 9, 47, 123. So they're quite different, and I don't know if it's going to make that much of a difference overall with the stain segmentation vectors, but I'm very curious about it. So if I say that I just want the hematoxylin in this one, are the outputs different? So let's try to find the same point. So let's do this sort of vortex there. You've got levels of 1.2109, and in here you've got much higher levels, 1.5, 1.43. Okay, so there definitely is a difference with the automatic stain separation when you use the same stain vectors, which makes sense because the images are not, even though they're images of the same thing, they're not the same image, and the colors are very different. So let's create some stain separation vectors that are particular to each of the images, and let's see how different they can be. Okay, so the tutorial says that we have several ways of doing this. The first way, let's try to do it in the same area. And let's do it in an area that doesn't have a lot of stain artifacts there. Okay, it says that we need to make a small annotation. Let's do the background first. So a small rectangle in an area that is representative of the stain you want to characterize or the background. And then double click on the corresponding stain under the image and follow the prompts to update. Okay, image, double click on the corresponding stain. Set color and convolution background values from region of interest. Yes. H&E modified, image, modified, and in here let's do the same, more or less the same area. Double click here, yes, modified. Okay, and you can see, are the values very different? So in this one is 246, 243, 243, and in this one, ooh, so they're very different. Cool. I'm glad I'm doing this with these two images. I think with this you can see quite well why it might be important to set your stain filters for your particular image. Okay, let's do the same for the other stains. So this looks pink enough, more or less same area. The same. This one is the Hamamatsu, and let's look at the pink one. Yes, yes, and the same for this one. Yes. Okay, and it's automatically updating the other ones as well. Cool. I'm gonna do the other ones anyway. Let's do this here. Yes. Where are we here? Where am I? Yeah, they look so different. The colors are so different. Okay. And this one is for pink compared to this purple one. That is the same. Yes. Okay. Cool. And it has automatically updated the residual thing. And now, if we... I don't want these annotations anymore. Can I just delete them and be okay? Yeah. Okay, so you can delete them and it's fine. Good. I want to see the difference when I do this. Are the values now more similar to each other? Still not the same. And this, ladies and gentlemen, is why ICC profiles are a problem that I hope someone wants to resolve at some point. I bet you, Hamamatsu, please just help us deal with this. Maybe? Okay, so... Okay, I'm going to find a representative region, which is not going to be a region with a lot of brown or green, so let's do that here. Okay, I like this one, and we'll just, is this the same area? Yeah, more or less. Okay, there and there. Okay, and now we're going to create an annotation where there is a bit of everything, so a bit of bright purple and a bit of pink. Let's add a bit of this as well, and that's a lot of brown here. Okay, find a representative region and then do this. So it says 245, 245, 244 do not match the current background values. Wait, this is the one where we checked and the background values were very different because this you can't call this white. This is brown. Okay. Analyze, estimate stain vectors. Do you want to use the model values? Do I say yes or do I say no? It says if the area that you've drawn contains a representative area of background, you should probably click yes. Yes. And look at that. Oh, I love seeing this kind of plots. So it says that for this image, this is how the stains are behaving. And I don't know if I can do this for two images at the same time. So I'm going to take a pic of this because I want to compare it. Save this for a bit. Okay, yeah, whatever. No, I don't actually want to save it. Okay, so since I want the same annotation in both places, I'm just going to copy this annotation. So edit, copy to clipboard, selected object, this object, edit, and edit, paste. Okay, there we go. And I'm going to do the same. Analyze, estimate, stain vectors, yes. And look how different the stains are. And that's why it's important to estimate your stain vectors for your own image, because they may be very, very different from what you're expecting, or because you always expect the perfect image, but you never get it, do you? Cool, so we know how to estimate the stain vectors and do these stain separations for an H&E single viewer. Okay, now we're going to try and do the same for the DAP. So this one is very different because it's immunous. So instead of purple and pink, it's brown and blue. And we're going to do the exact same thing. So we're going to first see what happens if you just use automatic values. But you're grabbing the blue as well. So this is just with the vectors. Okay, now let's do the same thing. And a really cool thing, I don't know if you've realized, but when you change these stain vectors, all of this text changes color to the color combination, whatever you've selected as a representative area. So if you saw before, hematoxylin was kind of purple, but now it's blue, and a very ugly tone of brown. It's not getting as much of the blues. And then, as before, let's do this one. And you can see it here. Okay, I'm gonna go get a fluorescent image. Okay, I'm back, and now I have a good fluorescence image. So let's add it to the project. We can set the image type here, fluorescence. Okay. Ooh, cool. And in here, the channels are actually different channels. They're not just colors, they're actual channels that have been given colors. And now we can, there's not a lot of blue here, is there? We can toggle the green. Let's toggle the green. There we go. And you can select which ones you want to see. Apparently you can select all of them. Show channels. Hide channel. Show none. Show all. Okay. And you can also use numbers to select that channel. So just 1, 2, 3, 1 and 2. So this only works up to 9, because if you do like 12, it selects 1 and 2. It is useful if you just want to see 2 of them and you don't need this. You can do it without the brightness and contrast window. And if you want to see the channels separately, apparently you can do view, show channel viewer. Ah, cool! And you can see all of them separately. And it's really nice. Yay! We've learned how to view different channels and separate different stains using color deconvolution with images with different color profiles to see why selecting the stain vectors for particular images is important, and for DAB images as well. So, hope you've learned something, hope you've enjoyed it, and I'll see you in the next video. Bye!